In this example problem, there is a pottery wheel that is rotating at 2.5 revolutions per second. Because it's revolutions per second, that tells us that it is an angular velocity, and it is going to be the initial angular velocity. But because it's in revolutions per second, we need to convert that into radians per second. So I'm going to use the conversion factor that 1 revolution equals 2 pi radians. So notice that the way I've set this up, the revolutions cancel out top and bottom, and you're left then with units of radians per second. So that means my initial angular velocity is going to be 15.7 radians per second. We're also told that a frictional force is applied to the side of the wheel, so it comes to a stop. So that tells me my final angular velocity is going to be 0 radians per second because it comes to a stop. And it comes to a stop after 3.5 seconds, so time is going to be 3.5 seconds. We want to know what the average angular acceleration of the wheel is. So given that we have the change in angular velocity and we have our change in time, I am going to use this relationship here to solve for average angular acceleration. So remember, delta omega is going to stand for final angular velocity minus initial angular velocity, and then we're going to divide by our change in time. And that allows me to find the average angular acceleration over here. Notice here that it is negative because the object is slowing down. So the object is decelerating, which is why we have a negative angular acceleration. And notice the units here. Because it's angular accelerations, it's going to be radians per second squared.